Hello everyone. In the previous lesson, we covered an overview of engineering geological investigation. This lesson will focus on one of the most critical methods in engineering geological investigation: engineering geological exploration. Engineering geological exploration is to further find out engineering geological conditions below the surface, such as the spatial distribution changes of rock and soil layers, burial depths and the type of groundwater, and the work that needs to be done when the geotechnical parameters are tested in situ. In addition, exploration involves sampling. Sampling is a work carried out to identify geotechnical characteristics and the various laboratory tests to provide the required samples. To provide the required samples, tasks of engineering geological exploration also vary with the stage of the survey, but generally speaking, it mainly includes 4 tasks. The first task, to prove engineering geological conditions, stratigraphic lithology of construction site area, variation of rock thickness, determine the properties, thickness, number of layers, altitude, and spatial distribution of weak rock and soil strata. Understand the depth, thickness, and distribution of bedrock weathering zones, and the location width and the properties of stratigraphic fault zones. Find out the degree of fissure development and the changes with depth. 2. To identify the number of layers, depths, and hydrogeological parameters of underground aquifers. 3. To carry out grouting, water pressure testing, and the soil mechanics parameter testing utilizing boreholes. 4. To carry out long-term groundwater level monitoring using boreholes for site dewatering, so as to ensure the stability of relevant structures of the site geotechnical web. The commonly used methods in geotechnical engineering exploration include the drilling, test pitting, and the geophysical prospecting. Drilling and test pitting are direct exploration methods, providing reliable geological data. Drilling is the most widely used type of exploration method, widely used in exploration of various projects, due to its potential for misjudgment or omission of certain critical geological bodies or phenomena. It is also referred to as a semi-direct exploration method. Test pitting refers to exploratory workings where personnel can conduct observation and logging to determine geological structures. However, heavy test pitting is expensive, with long exploration cycle. Unlike drilling and test pitting, geophysical exploration is an indirect exploration method. Next, we will introduce these 3 exploration methods in detail. First, geophysical exploration, also called geophysical exploration. It uses specialized instruments to detect the distribution of physical fields in various geological bodies, analyze and interpret its data, so as to divide strata and judge geological structure and hydrogeological conditions, as well as an investigation method for various unfavorable geological phenomena. Since geological bodies have different physical properties, such as conductivity, resiliency, magnetism, density, radioactivity, and different physical states, moisture content, porosity, and the degree of consolidation vary. This provides a physical basis for utilizing geophysical methods to study various geological bodies and phenomena. Currently, the geophysical exploration methods commonly used in engineering projects mainly include electrical methods, magnetic methods, gravity methods, seismic methods, and the radioactive methods. The geophysical measurements in boreholes are also referred to as geophysical well logging, as well as geophysical remote sensing measurements. The resistivity method is a commonly used geophysical technique in engineering. It relies on artificially establishing a direct current electric field to measure variations in resistivity either vertically or horizontally at the surface, thereby inferring the properties of geological formations. The resistivity method can be utilized to delineate lithological strata, geological structures, the thickness of overburden or weathered layers, the distribution and the depth of aquifers, as well as distribution range of paleochannels and natural building materials. It is usually widely used when searching for groundwater. Seismic exploration is also a common geophysical prospecting method. The geophysical exploration method involves artificially generating seismic waves and analyzing their propagation characteristics within the Earth's crust to investigate geological structures. High frequency is the most widely used in geotechnical engineering survey. Typically referred to shallow refraction method, typically utilizes seismic waves with frequencies less than 200-300 Hz. By probing the refraction pattern of seismic waves, it is possible to study geological bodies with depths up to 100 meters. In addition, the commonly used geophysical methods in engineering include the ground-penetrating radar, or the geological radar method, and test methods for gravity exploration. Different from geophysical methods, test pitting is an exploration method involving the excavation of small cross-section trenches or tunnels from the surface or underground to expose geological features, followed by corresponding investigation work. Test pitting allows direct observation of geological structures, providing accurate and reliable data. It facilitates sketching and enables unrestricted collection of undisturbed rock and soil samples, as well as the execution of large-scale in-situ tests. The use of test pitting is often constrained by natural geological conditions, involves high costs, and requires lengthy exploration cycles, particularly for heavy pit exploration projects, which should not be undertaken lightly. The common exploration methods in geotechnical engineering investigations include trial pits, trenches, shallow shafts, vertical inclined shafts, adits and crosscuts, drifts. Trial pits, trenches, shallow shafts are light-duty pit exploration works, which can be achieved by manpower mining. The shafts, adits, and crosscuts are heavy pit exploration works, which requires the cooperation of mechanical equipment for construction. Finally, let's introduce drilling. Drilling refers to the process of breaking up crustal rocks or soil layers using specialized equipment or tools to create a borehole with a relatively small diameter and considerable depth. When the diameter is relatively large, it can be called drilling. Drilling can be carried out in a variety of environments, generally not limited by topographic and geological conditions, and supporting direct observation of core and sample with high exploration accuracy, capable of providing in-situ testing and monitoring. To maximize comprehensive benefits, large exploration depths and higher efficiency are the advantages of drilling. Drilling can address geotechnical stability, deformation, and seepage issues related to buildings or structures, while providing essential data. It can directly determine the lithology, geological structure, groundwater depth, aquifers, and their thickness, as well as identify landslide locations and karst conditions. It also allows for core sampling and in-situ testing within boreholes. The commonly used drilling methods in engineering include percussion drilling, rotary drilling, vibratory drilling, and flush drilling. Then can these methods be directly evaluated for their applicability to the strata? Do not move soil samples, and so on. There is a big difference. When making your selection, refer to this table for guidance. In compliance with the type of soil layer, and the relevant investigation requirements, select the appropriate drilling method. When only the entire soil layer needs to be investigated, we can also use some small caliber twist drills to perform drilling. For small diameter drilling, a spoon auger can be used, and even a Luoyang shovel may be employed for the drilling process.